Oh, hello again and welcome to the VK6CS Fun with Amateur Radio channel. I've been having some fun today. I've been mucking around with my high voltage power supply trying to make the soft start circuit work, and I think I've cracked it. It seems to work fine. It's a bit of an unusual arrangement, but it's doing exactly what it needs to do, which is switch out the current limiting resistors to the primary of the high voltage power supply after they've done their job of reducing or restricting the inrush current. Okay, so I'm going to flick the switch and it should just power up. Should be no nasty buzzy noises, no smoke, no flames, no explosions, etc. So I'll flick the switch. It's okay. You can leave your fingers out of your ears this time. And there we go. As you can see by the what will be the front panel high volt meter, it's showing just a whisker under 2,800 volts. Now I won't get my calculated 2,828 volts because I don't have 240 volts of mains. I've only got it sort of varies a bit here, but it's it's closer to 230 volts than 240, so it's going to be a whisker under 2,800. That's what the meter's indicating. I'm going to stick the high voltage probe on, see what it actually is. Of course, the bloody man! Can you all the time for the meter to time out? Can you imagine? 2.79. Now remember, that's times 1,000, so that's 2,790 volts. 2.79, 2,900, 2.79, 2,790 volts, and as you can see, that's just a whisker under 2,800 volts being indicated on my panel meter there. So that's all looking fine. Now I'll just switch it off. So what have I done? What have I done to make it work? Well, it looked like a bird's nest before, and it looks even more like a bird's nest now. Let's pan out a bit. I have to buy a lotto ticket. I actually got that the right way around. Good heavens. Right, so what I've got is got a couple of 10 ohm resistors in parallel there, and a couple of 10 ohm resistors in parallel over here. These here, that's giving me 5 ohms apiece. I've still got my 3.3 ohms here and here, and I've added a 2 ohm here in series with this 3.3 ohm here. Now I didn't have another one to put on the other side, so I'll draw the circuit diagram and I'll show you what I've got. Let's get the camera around there a little bit. Oh, well, see what we can do with this. So it goes round like that to the board. Oops. Focus. Come on. Thank you. Okay, let's see if I can get this so that it's there we go. Right, now I'll show you what I've done. Let's hope that it stays in focus. You've got the mains comes in. I thought I'd use that one because the other one I think is running a bit low on ink. I'll try the other one. The focus was probably perfect before, it'll probably be out of focus now. I've changed pens. Okay, so what I've got is mains comes in, goes through an 8 amp fuse. I'll probably change that to a higher value. Goes through a 5 ohm resistor, goes through another 5 ohm resistor, the other leg of the mains, 5 ohm resistor, and at the moment a 3.3 ohm resistor. That goes along there, and that goes to my transformer primary, like that. So that's 5 ohms, that's 5 ohms, that's 3.3 ohms, and that's 5 ohms. Okay, so, and the reason this is 5 ohms is there's two 3.3 ohm resistors, one here and one here, and this one's got a 2 ohm resistor in series with it. I didn't have one to put on this side, and in the final circuit I will probably have 5 ohm, 5 ohm, 5 ohm, 5 ohm. If it doesn't work, then I'll just put it back to how it is, but it'd look nicer if it'd look a more linear design if they're all 5 ohms. Now the relay coil is here, like that, and the relay contacts are like that. Like that. So the relay shorts out all of the current limiting to the primary of the HT transformer. Now what it doesn't do is short out the resistors as far as the relay coil is concerned, because you know, once this is shorted out, you're still going to have these resistors in series with the relay coil, but because they're 5 ohm, and once this is shorted out, they'll be in parallel. So that's going to be 2.5 ohms there, and it's going to be 2.5 ohms here once that's a 5 ohm. This relay coil only draws less than 17 milliamps of current, so it won't even see those. It won't even see that the 2.5 ohm resistor there and there. Once it's energized, that'll sit there forever like that and be quite happy. So that's the circuit diagram of the high voltage power supply soft start circuit. And the reason this doesn't make the buzzing noise is that by putting this relay coil here, this voltage here will rise quicker than that voltage there. Not by much, but just by enough that this will pick without buzzing. So there we go. And of course, you know, I won't have 2 resistors in parallel there and 2 in parallel there and 2 in parallel there. This will only be 4 resistors. I'll get the appropriate values at the appropriate power ratings. So there's just 4 components there. So that'll be nice and neat. This relay is the contacts are 30 amp contacts. So that's you know, very well rated for the job they're doing. They'll be fine doing that and should do that for many years. I'll probably change that to 10 amp. Put a 10 amp fuse in there. So there we go. That's what I've been doing today, and I'm a little bit happier now that I know that I won't have to resort to using one of the lower voltage power supplies. You know, one of the relay supply or something like that. You know, putting a little having this relay as a 12 volt relay to short these out, and just having the 12 volt rail, something on that to provide the slow start. I'd much prefer to do it just with the HT, because if you do it with the HT supply, that's the supply you're dealing with. You know what the score is with it. Whereas if you've got to rely on another supply for the soft start, then you can have problems. But that is nice and simple. It's got no silicon components in it. It's just a few resistors and a relay, and there we go. So I hope you found that. Interesting. As always, thanks for watching, and I'll catch you next time.